Welcome friends for the lecture of arc extinction in the circuit breakers. The main purpose of a circuit breaker is to switch the load currents, make onto a fault, break normal and fault currents, carry fault current without blowing itself open. Means when there is a fault, so in this fault condition we are applying the reclosing, and during this reclosing if fault persists in the system, so the circuit breaker contacts make on the fault current. It breaks the circuit in normal and the fault currents. When the relay senses the fault current, it picks up and it closes the contact so that the tripping signal it is given to the trip coil of the circuit breaker. So during this time period, the circuit breaker contact must carry this fault current without blowing itself. So the important characteristics from the protection point of view are the speed with which the main current is opened after a tripping impulse is received, the capacity of the circuit that the main contacts are capable of interrupting the fault currents. The first characteristic is referred to as the tripping time and is expressed in cycles. Modern high-speed circuit breakers have tripping time between 3 and 8 cycles. The tripping or total clearing or break time is made up as follows. Opening time, the time between instant of application of tripping power to the instant of separation of the main contact. The arcing time, the time between the instant of separation of the main circuit breaker contacts to the instant of arc extinction of short circuit current. When the trip coil receives the supply for the energizing and when it unlatches the mechanical mechanism so that the contact they start separating, from that instant of the separation and up to the opening or full travel of the moving contact. When the contacts they start separating, the arc is formed in the circuit breaker and the arc is extinguished. That time is called as a arcing time. So the total break or clearing time for the circuit breaker is the sum of the opening time and arcing time. So the total break or clearing time, it is explained in this diagram. So this is the instant fault occur in the system. So at this instant the relay sends a relay pickup and it closes its contact. So this time is called as a relay time. And when this contact of relay they closes, so they give the supply to the tripping coil of the circuit breaker. So at this instant the trip coil is energized, and this trip coil is energized and it unlatch the mechanical arrangement in the circuit breaker so that the contacts they start separating and the moving contact move to its final position. And when this contact they start opening, the arc is formed in the circuit breaker, and when this arc is extinguished, so this total time, circuit breaker opening time and the circuit breaker arcing time, this is called as a total break or clearing time for the circuit breaker. Okay, opening time plus arcing time. So when the two current carrying contacts open, so this is a fixed contact and moving contact. So when circuit breaker is closed, so these two contacts they are pressed each other against the spring force, so that the current is flowing in this contact of the circuit breaker during fault condition. When these contacts opens, an arc bridges the contact gap and prevents an abrupt interruption of the current. So it persists during the brief period after separation of current carrying contacts. Just we see the circuit breaker opening time, it is measured in terms of cycles, 3 to 8 cycles, okay, and one cycle is of 20 milliseconds. So minimum opening time is 60 milliseconds. So in milliseconds, this circuit breaker, it opens its contact, and for the very short duration this arc persists in the circuit breaker contact. The electric arc is a self-sustained discharge of electricity between electrodes in gas or vapor. So this electric arc is the self-sustained discharge between the two contacts in the circuit breaker. In AC alternating current arcs, as the current becomes zero during the regular wave, the arc vanishes. When the current it passes through the zero line, so at that instant the magnitude of current is zero, and at this instant the arc is vanished and it is prevented from restriking. The molecules and atoms are electrically neutral. The ionized matter consists of charged particles such as ions and electrons. When the temperature being gradually increased, the molecules experience a motion in all sort of direction. At higher temperatures, the velocity of particles increases and they collide against particles coming in their ways. Dissociation takes place at temperatures of the order of 3000 degree Kelvin. The molecules break up into simpler form such as molecules and atoms. So the molecules and atoms, they are electrically neutral, but when they ionize, the charged particles, ions and electrons, they are dissociated at the higher temperatures. So when the temperature increases, the velocity of these particles, it is also increases and they collide against the particles coming in their ways. And because of this collision, again the dissociation takes place at the temperature of 3000 degree Kelvin, and these molecules, because of this collision, they breaks into simpler form of these ions and electrons, and these molecules or atoms, they start dissociation. So the temperature is further increased to 3000 degree Kelvin. The internal forces which holds the electrons to the atoms are affected and the electrons manage to escape. Further, if we increase this voltage to this 6000 degree Kelvin, the electrons, they escapes from the atoms and the atom becomes truly charged, and the electrons may attach a neutral atom or may remain free. So this is called as the ionization of the matter. So further increase in the temperature enhances the process of the ionization and plasma state is reached. Further increase in the temperature, so this ionization process, it reaches to the plasma state, and this plasma state consists of the charged particles Okay, ions with positive charge and electrons with the negative charge. So this is called as a plasma state. So in this plasma state, there is a total ionizations. These electrons, they are separated or they are dissociated from the atoms, and there is only positive ions and the electrons. The conductivity of plasma depends upon number of ions per unit volume. So this plasma is the conducting medium for electric current. The ionized gas is a conducting medium. So this plasma state is the conducting medium. The circuit breakers, the contact space is ionized by the following causes. So when the contact of the circuit breaker they opens, the arc is formed, and between the contact of the circuit breaker, so there is a ionized conducting medium, or the plasma is present between the gap of the contact. So the ionized causes because of these 5 reasons. First, thermal ionization of gas. Because of the temperature, high temperature, the gas or the medium between the contact, it ionizes. Then ionization by collision of particles. At the higher temperature, the atoms, they collide with each other, and because of this collision, the more heat is generated, and simultaneously these electrons, they gain the energy and they separate out from the atoms. Thermal emission from the surface of the quantum. Because of this temperature, the electrons, they are emitted from the surface of the contact. Secondary emission from surface of the contact. Then the field emission from the surface of the contact. So when these contact they separated, the voltage is there across the contact, and because of this voltage or because of this electric field across this contact, there is an emission of the electrons from the surface of the contact. Now we discuss the ionization of these 5 points. Thermal ionization. So at the normal temperature, the molecules of gas are in the state of constant agitation, and they move at various velocities in various directions. A molecule at velocity v and the mass m possesses the kinetic energy is equal to 1/2 mv square. 1/2 mv square. Okay, and the kinetic energy, it is also written as 3/2 kT. So here this K is Boltzmann's constant and T is the absolute temperature in degree Kelvin. And at this 3000 at 300 degree Kelvin, these air molecules, they move at 500 meters per second. And as the temperature increases, so the speed is also increases. And at the temperature about 3000 degrees centigrade, the molecules break up in the simpler form and further to the atoms. Okay, so these molecules, they break up into the atoms at 3000 degree centigrade. So this process is known as a dissociation. This process is known as a dissociation. At 3000 degree centigrade, these molecules, they break up into the form of atoms. This is called as a dissociation. And at higher temperature, about 6000 degrees centigrade, the agitation of these atoms is vehement and their impact against each other can produce ionization by mutual collision. Means they are showing very strong feeling at this higher temperature. Okay, because of this agitation, and there is a mutual collision of these atoms, and this type of ionization brought about by the heat. Okay, because of this temperature there is a breakup of molecules into the atom. As this temperature increases, so there is a further mutual collision in the atoms. This is called as a thermal ionization. Okay, and the frequency of this collision is 10 to the power 10 times per second. Okay, so this is the speed of collision, 10 into 10 to the power times per second. Okay, so at this higher rate they collide with each other. So this ionization is called as a thermal ionization. Then ionization by collision. Okay, so as a particle at the higher velocities may strike the another particle, thereby the energy of moving particle is imparted to the other one, and this energy may be enough to dislodge the electrons from the atoms. So as we discussed, the energy is 10 to the power 10 times collision per second. Okay, so this is the rate of collision of this moving particle, and at this higher rate they will collide with each other, and because of this collision they dislodge the electrons from the atoms, and this is called as a ionization by collision. Next is a thermal emission from surface of contact. So in a closed position, the contacts are pressed against each other at a high pressure, causing plastic and elastic deformation. As the contacts start separating, the pressure between contacts reduces. When the contacts they are closed, so the moving contact it press with the spring force, okay, with the fixed contact, and the high pressure, the high spring pressure, it causing the plastic and elastic deformation. Now when the contact they start separating, the pressure between the contact reduces first, and thereby the true area of contact is reduced to area of a few spots on the surface, and the current crosses the contact surface at the spots, producing the high current density. So these current densities are 10 to the power 7 to the 10 to the power 12 ampere per square meter. Okay, so these are the very high current densities are there in the contact, and because of this higher current densities, the spots they will produce a high current. Okay, so at this spot these are the higher current densities they are formed. So therefore the spots of high local temperature are produced at the surface of the contact. So the arc has high temperature as the energy is dissipated in the form of heat, and by virtue of this causes the thermal emission takes place at the contact surface. Okay, so here in this diagram we can see this is the closed position of the contact, and the pressure spring force it is applied on this moving contact, so that they are in the plastic an elastic deformation so that the current, fault current, it is flowing through this contact without generation of heat. When the contact it start separating, the pressure is reduces and some hotspots are formed on the surface of these contacts, and the 10 to the power 7 or 10 to the power 12 ampere per square meter, these high current densities are formed, and because of this higher current densities at these spots, the local temperature is generated. Okay, so the local temperature is generated, and because of this high temperature, the energy is dissipated in the form of heat. I square R loss is there and the heat is generated. So this is called as a thermal emission. This is called as a thermal emission at the contact surface. Then next is a secondary emission at the contact surface. The electrons moves rapidly under the influence of the strong electric field between the contacts and strike the surface of the other contact. Thereby, they produce the emission from the contact surface by the collision. So these electrons, they strike on the surface of the other contact, and because of that there is a emission. This is called as a contact surface emission, field emission at the contact surface. If the voltage gradient at the surface of the contact is high, the electrons can be dislodged from the surface of the electrodes. So when the contact they start separating, so the voltage is increases as the distance increases between the contacts. So this voltage across this contact, it is also increases. So this voltage gradient is experienced by this contact or by this gap. Okay, and because of this voltage gradient, the electrons can be dislodged from the surface of the electrodes. As contact separates, the distance between them being too small initially, and high potential gradient appears near the contact surface, kV per centimeter. Okay, so this is a voltage gradient, means per mm how much kilovolt it is appeared across this gap, that is called as a potential gradient, and the gradient can be more than 10 to the power 6 volts per centimeter, and this is enough to break down the gas. Okay, and because of this higher voltage gradient, the gas between the contacts, it is break down. So this ionization produced by the electric field called as a field emission. Because of the voltage across the contact, the gas, it is break down. This is called as a field emission. This field emission or this voltage gradient at the surface of the contact is high, and the electrons can be dislodged from the surface of the electrodes. Okay, so here we can see, so initially the gap, there is no gap, so the voltage is 0 across this contact. As this contact they start separating, so the voltage gradient, it is increases with the delta T. Okay, distance or length between the contact. The voltage gradient is equal to V upon delta L. If V is equal to 1 kilovolt and delta L is equal to 1 mm, so gradient is 1000 volts per mm. So as the contacts separate, the distance between them being too small initially, high potential gradient appears near the contact surface, and this gradient can be more than 10 to the power 6, and this is enough to break down the gas. And because of this electric field, there is a breakdown of the gas, and some electrons they dislodge from the surface of these electrons. Okay, so because of this field emission, the electrons they dislodge from the surface, and there is a breakdown of the gas. Next is a photo emission. The electron emission from the contact surface caused by the incident of light energy is called photo emission. So when the arc core is formed, so it has a very high temperature and it will produce a light energy, and this light energy is emitted on the surface of the contact, and because of this light energy, the electrons they are emitted from the surface of this fixed and moving contact. It is called as a photo emission. Because of these hot spots, very bright light it is generated. At the same time, because of this arc core, the light is generated, and this light energy or light it is incident on the contact surface, so they will dislodge some electrons, or they will remove the electrons from the contact surface. This is called as a photo emission. So in this way, the arc is formed across the contact of the circuit breaker. Now there is a opposite procedure that is called as a deionization, and deionization can take place by the processes of recombination or the attachment. Okay, so recombination of these electrons and ions, they will form atom. Again they will recombine, they will form a molecule. Okay, then diffusion and drift energy or the conduction of heat. We remove the heat between the contact. Okay, so because of that, there is a deionization. Okay, so in the recombination, if the gas containing the positive ions and electrons, there is a tendency for these to come together and combine to form a neutral atom. So they are the opposite polarity, positive and negative. Positive ions and electrons, they are negative. Okay, so there is a tendency to come together and to form a neutral atom. So this phenomena is called as a recombination, and this recombination takes place directly in the gas, and this is important in the process of arc extinction. So when these electrons and ions they recombine with each other, so that the arc is extinct, arc is interrupted, or arc is extinction. As the ions penetrate from the heavily ionized space near the arc to the walls of the container, electrons reach the walls first as they are light. So in this arc core, the electrons they are light, so they form a wall near the dielectric or near the insulation where the contacts they are placed in that chamber. As a walls are insulating material, electrons cannot escape, and the inner side of the container is negatively charged. Okay, so in the ion core, there is a positive ions are there, and these electrons they are negatively charged, they are light in the way, so they are accumulated near the walls of this insulating material. As the walls are insulating materials, electrons cannot escape, and the inner side of container is negatively charged. So thereafter the wall inner surface repel electrons and attract the positive ions. Okay, so these electrons they are repelled and they will attract the positive ions. So in this way the combination takes place between positive ions and negative charges. Diffusion. The electrons from highly ionized space, they diffuse to the surroundingly weak ionized spaces. So this is an important process in building up the dielectric strain. Conduction of heat. So conduction of heat brings down the temperature and assists the recombination. Okay. So as the temperature increases, so these molecules they separate and the atoms they are formed. Again at higher temperature, these atoms they dislodge, or there is a dissociation, and the electrons and ions they form. So there is a opposite action is there. If we remove this heat, so the ions and the electrons they recombine, or the partial of higher temperature travels to the space at lower temperature. So in this way the kinetic energy is removed from the ionized spaces between the contacts. Okay. So this deionization is an important process with the recombination, diffusion and conduction of heat. Okay. This is the deionization, and it is an important process because it assists the arc extinction. Now we'll see the nature of waveform in the alternating current arc. The characteristics of AC arc current and voltage with respect to time. The voltage across the arc is in phase with the arc current. Okay. So here this is the voltage and this is sinusoidal is the arc current. So in alternating current, the arc voltage and the arc current they are in phase with each other because it is a predominantly resistive in the nature. The voltage across the arc reverses with the current. At current 0, the voltage across the contact reverses. Okay. So when the current is 0, that voltage, arc voltage, it is also 0. When current reverses, this arc voltage, it is also reverses. So because of the resistive nature of the arc, voltage and current, they are in phase. The arc extinction can be classified into the following three categories: high resistance interruption, current zero interruption, artificial current zero interruption. Okay. So with the help of these three methods, the arc between the circuit breaker contacts, it is interrupted or it is extinguished. Now we'll see these three methods one by one. High resistance interruption. The high resistance interruption is obtained by increasing the resistance of the arc. Okay. So our arc, resistance of arc is equal to voltage across the arc divided by current flowing through the arc. Okay. So R is equal to V upon I. So assuming this I arc current to be constant, the resistance of arc can be increased by increasing the voltage of the arc. So we assume the arc current it is constant. Arc current it is constant. Okay. So this resistance of the arc is increased with the increase of the voltage, arc voltage. Okay. And this V arc can be written as A plus B D plus C plus D upon I arc. Okay. And in this equation, so this D is the length of arc and this A, B, C, D, these are the constant of this arc chamber. Okay. So based on the design of the contacts, so these are the constant. The arc voltage, hence the arc resistance can be increased by increasing the length of the arc. Okay, so from this we can see as the D is increases so this voltage is also increases. Okay, and this voltage increases, so this arc resistance it is also increases. Okay, so in high resistance interruption method, the length of the arc is increased so as to increase the voltage across the arc. Okay, so by increasing the length, we can increase the voltage, and with this increase in the voltage, the resistance of arc is increases. So the voltage of arc is increased till it more than the system voltage across the contact. Okay. So we have to increase this voltage at such a level that when the contact they are fully separated, so system voltage is observed by this contact, and we have to increase this arc voltage in such a way that this V arc is more than the system voltage. Okay, and when this condition is achieved, the arc is get extinguished. Okay, so the method is used in low. This method is used in low and medium voltage AC and DC circuit breakers. Okay, how this high resistance it is achieved? So there are three methods: lengthening the arc by means of arc runners. Second, splitting of arc, and cooling of arc. Okay, so in these three ways, so we can increase the arc resistance. Lengthening the arc. Arc runners are horn-like blades of the conducting material which are connected to arcing contacts with their tips radiating upward in the V shape. Okay, so these three number these are the arcing horns. Okay, so they are in the V shape. So at the bottom there is a small gap, and on the upward side they are open with the more distance between them. The arc originates at the bottom and blow upward by the electromagnetic force. Okay, so this arc is taking place at this bottom near V shape where the distance is very small, and with the help of Fleming's left hand rule, this is the direction of field and this is a direction of current. Okay, and this thumb it will indicate the direction of force in the upward direction. Okay, and with this electromagnetic force, this arc moves in the upward direction. So the tips of the arc more upward along the arc runners or arc horns rapidly. Okay, so because of this electromagnetic force, so this arc moves in the upward direction with these arc runners. The length of arc increases and the arc is extinguished. Okay, so here the length of arc is less. As it moves in the upward direction, the length of arc increases. Okay, so as the length of arc increases, the resistance it is also increases, and the arc vanishes at this position number 2. Second method, splitting of arc. The arc is elongated and split by the arc splitter. Okay, so here this is the arc, and these dashed lines they will indicate the arc splitter. These are the arc splitter. Okay, so these arc splitter they are made of the resin bonded fiberglass. Okay, so that they can withstand at the higher temperature of the arc. So these are placed in the path perpendicular to the arc. Okay, so when this arc moves in the upward direction, so that the plates and the small area of this plate it is a perpendicular to this arc. Okay, and with the help of this arc runners, metallic arc runners. So this arc moves in the upward direction and it elongates with the help of this arc splitter, so that the length of the arc it is increases. So the arc is pulled into them means arc splitter by electromagnetic force experienced by the arc by means of magnetic field applied in the upward direction so as to pull the arc upwards. So when the arc is pulled in space between the plates, it gets elongated, constrained, split and cooled. Okay. So the length of arc it is increased. At the same time, the arc it is get cooled in this splitter. Okay. So by virtue of this effect, the arc get extinguished. Okay. So there is a cooling, there is a lengthening of arc. So the resistance it is increased, and at the current zero, the arc is get vanished. Third, cooling of arc. Cooling of arc brings about the recombination of the ionized particles. Cooling removes the heat from the arc, and cooling is brought by bringing the arc in contact with the cooler air. Okay. So in this way, the heat from the arc it is taken away, so that there is a recombination of the ionized particles. The heat is removed from the arc, and this is done with the help of cooler air or the cooler gas. So next method is a low resistance or 0-point extinction. So this method is employed in alternating current arc interrupt. So actually the alternating current passes through 100 times per second in 50 cycles current way, 50 hertz per second. So there is a positive cycle, there is a negative cycle. So in one cycle, this wave passes 2 times through this 0, and for 50 cycles, it is 100 times. At every current 0, the arc vanishes for a brief moment. However, the arc appears again with rising the current waveform. Okay. So for this, so there is a current 0, negative side, current 0, positive side. Okay. And with this arc voltage is also 0. It goes to negative side, it's 0. Okay. So at this instant, the arc is vanishes. Okay. Or it is interrupted at this current 0. And at this current 0, the space between contact is deionized. Okay. So at this current 0, the space between contact it is deionized. Okay. And quickly by introducing the fresh unionized medium such as oil or fresh air or SF6 gas between the contact. So in this way, for AC supply system, the arc it is vanishes 100 times in a second at the current 0. So the dielectric strength of the contact space increases to such an extent that the current does not continue after current 0. A high voltage may appear across the contacts. The voltage may re-establish the arc if dielectric strength of gap is less than the restriking voltage. In that case, the arc continues for another half cycle and may get extinguished at next current 0. Okay. So when the current 0 is there, so we are applying the dielectric strength between the gap so that the arc is extinguished. And if the dielectric strength is less, then the restriking voltage may appear across the contact. So in various type of circuit breaker design, the provision is made to remove the hot gases from the contact space immediately after the arc, so as to fill the contact space by fresh dielectric medium of high dielectric strength. The arc extinction process can therefore be considered to have three phases. One, or first, arcing phase; second, current zero; and third, post arc phase. Okay, when arc is extinguished, so after that the post arc phase. So there are the theories developed for the arc interruption. First is the Slepian. So he developed the first theory for the arc interruption in 1928-30. Next, Prince postulated the displacement theory in 1931. So this Slepian and Prince, both they are from the USA, and these cases of UK, he put forward another theory in 1938. Then Mayer of Germany, he put another theory similar to the cases theory. Okay, so they developed the various theories based on the deionization and this arcing phase, current zero, and post arc phase. So based on this, they they developed the theories for the arc interruption. Slepian's theory. Slepian described the arc extinction process as the race between dielectric strength and the restriking voltage. After the current zero, there exists a residual column of the ionized gas. If the dielectric strength builds up rapidly so that it is always greater than the restriking voltage, so the arc does not restrike. If dielectric strength is less, the arc restrikes. So there are three curves. Dielectric strength is shown by the curve A and C. Okay, so here curve A for dielectric strength, C for dielectric strength, and curve B is restriking voltage. So if the dielectric strength of the contact gap is more, dielectric strength of the contact gap, it is more than this restriking voltage. Okay, so this we can see in the first figure. Dielectric strength, build-up of dielectric strength, it is more than the voltage stress or restriking voltage. Okay, so in this case the arc is interrupted. Dielectric strength is more than the restriking voltage. Then second condition, if this dielectric strength or the dielectric build-up rate, it is less than the restriking voltage, so the arc restrike again. Okay, so it is shown here. So this is a voltage stress. Okay, so in both figure or in this figure, it is a same rate. Voltage restriking rate, it is same. So we have to change the rate of build-up of this dielectric strength. Okay, so that is we can change. So in this case, if this dielectric build-up rate it is less than this voltage stress, the arc restrike. Okay, and this is explained or this theory, it is developed by the Slepian theory, and it is also called as a race theory or recovery rate theory. Okay, so for this, the Slepian he assumed some parameters, and because of these assumptions, this is also called as a drawback or limitations of this Slepian's theory. Okay, so he assumes that the restriking voltage and build-up of dielectric strength are comparable. Okay, because these two are the different quantities, but he assumed they are comparable quantities. The assumption is not quite correct. These two entities are not identical. Okay. So these are the limitations. Secondly, this theory does not consider the energy relations in the arc extinction. Okay. So when the contacts they are say pressed against each other, so at that the voltage is zero, resistance it is zero, and current it is flowing. When these contacts they are separated, so the voltage is gone increasing. So the when contact separated, the resistance it is increasing. So the energy supplied to the arc it is not considered. So this theory does not cover the arcing phase. Hence, it is incomplete. So these are the limitations of this Slepian's theory. And the Cassis, he developed the new theory based on this energy balance theory. Okay, so this is called as the energy balance theory or Cassis theory. Okay, so these Cassis also assume some conditions, or there are some assumptions for the energy balance theory or Cassis theory. First, the arc consists of cylindrical column at a substantially uniform temperature over its cross section. There is a uniform distribution of energy in this column, that is, volume energy density is constant for the complete column of the arc. Okay. So, but we see in the arc at the center of the core, the heat is more, and as we move away from the center of the arc, the temperature of the arc it is reduces. But Cassis assume that it is a cylindrical column and the temperature is uniform. Okay, so this is assumption by the Cassis, and the energy density is constant. The temperature remains constant. The cross section of arc adjusts itself to accommodate the arc current. Okay, so as the contacts they are separated, or with the sinusoidal waveform, he assumed that the cross section of the arc is adjusted itself to accommodate the current. Okay, as the instantaneous value of current from 0 to its peak and from peak to 0 it is changes, but with this change in this current, the cross section of the arc it is adjusted. This is an assumption by the Cassis. Then power dissipation is a proportional to the arc cross sectional area of the arc column. So these are the assumption. Again, these are the limitations developed by these Cassis for the energy balance theory. So this Cassis he expressed the energy equation as dq by dt is equal to EI minus N. So this E is volts per centimeter. Then Q is the energy content per centimeter of the arc length. I is a total current. So EI is a power input to the arc, volts per centimeter, and total current. And N is a total power loss per centimeter. Total power loss per centimeter. So this breakdown occurs if power fed in the arc is more than the power loss. Okay. So this power P is equal to E into I. Okay. So this P is equal to V multiplied by I. So at this instant, when contacts they are fixed with each other, so here the voltage is 0 and current I it is maximum, and say small I max. So here the power P is equal to 0. Okay, and again, so here the P is equal to VI. Okay, and at this instant the contact they are separated, so the resistance it is very high. Okay, and because of this high resistance, So the magnitude of current flowing through this, it is 0 or it is very negligible. So at this instant, the power input is less than the power loss. Okay. So this power input is less. This is not sufficient for this power loss. Okay. And the arc, it is extinguished, and the arc is extinguished. Okay. So this is the energy balance theory developed by the Cassis. So we summarize that the arc extinction can be obtained at current zero by building up dielectric strength of arc rapidly by dissipating the energy fed into the arc. The arc extinction process can be considered in three different zones: arcing zone, current zero zone, post arc zone. During the arcing zone, the thermal stresses produced by the arc are predominant. In every circuit breaker, an attempt is made to reduce the arc diameter by using various techniques. The current zero zone provides the transition. During post arc zone, the voltage stresses becomes predominant. In every circuit breaker, an attempt is made to introduce fresh dielectric medium between contact space after final current zero, is that the dielectric strength is rapidly gained. Thank you for patience listening.